Thank you guys again for joining in, and thanks to Localhost for the platform. This is a growing community, getting bigger and bigger every day. So it's a privilege to be here actually. So basically today, what I would be talking about is basically I termed it as filtering out the noise while keeping up with trends. Basically the reason I kind of struggled a bit for like a topic or like what to term this talk as, but basically it just like came to me. So because in the field DevOps, it's quite a lot. You hear a lot of tools out there, a lot of new processes and all. So basically the talk for today is just about filtering out the noise while keeping up with trends. And one major one I picked out was like DevOps is dead and long live platform engineering. I don't know if anyone on the call here has heard about platform engineering and what it's about and all, but it seems like a new movement in the DevOps space, and it's getting a lot of traction basically. So that is what we are going to be discussing about today. And just to kind of give us an idea what it's all about, for those of us that have not like stumbled upon it and what it's all about, like what is actually talking about, basically how to get started if it's a new thing, or basically your posture, where you stand with this new trend in this DevOps community. So kicking off, like it's basically DevOps engineering would go down in history as a very controversial job role. Basically some group of people, like a very good number of people, don't see DevOps as a job role. It's more like you hear most people is more like a culture, a process, a team or group of like a team of engineering should abide to. So it's more like a process and a culture instead of a job role, basically, if you're to go deep down into like the foundation and how DevOps basically started. But a good amount of people, of course, would say it's a job role. And basically, they don't come out to say it's a job role. Everybody just flow with the tides, basically. DevOps engineer wanted or DevOps engineer needed, yeah, apply and stuff. So basically, DevOps is like a big force, right? And there's a lot happening in this space. So basically, just to talk about, like, everyone seems to agree about like some of the core values, but not everybody agrees that it's like a job role. So what we've seen often is some organizations prefer not to use the term DevOps engineering if some of us are like very good at like making research and all. For instance, if I remember correctly, Google, you wouldn't see a role DevOps engineer in Google. Instead, you see site reliability engineer. Some organizations I've seen use cloud engineering. I've actually been in a team where we had a new manager, and the first thing he did was to basically say, I don't believe in DevOps as a job role. We need to change the name of the team. So the very first thing the manager did was to change the name of our team as at then from DevOps to cloud engineering. So I've also been in a team where the name was transitioned from DevOps to infrastructure engineering. So this happens a lot. If you've been like listening, you would have heard about this conversation. This discussion is never ending, whether DevOps is a role and all, but we would not like dispute the core values, whether it's cloud engineering, whether you're doing SRE, depending on the organization, whether you're being called DevOps. There are some things that revolve around this, which is termed as like infrastructure reliability and improving developers' experience. So basically, this is like a very broad umbrella onto which like DevOps stands. So for instance, everything you do as a cloud engineer or SRE or like DevOps engineer, most of what you do kind of developer facing and infrastructure facing. So infrastructure facing is you have to build new tools and new process to ensure infrastructure reliability. It's very important we like keep those two terms, because basically anything you look at in the DevOps space falls in between infrastructure reliability and improving developer experience. So basically, whether it's SRE in Google or whether it's a production engineer at Meta or whether it's a cloud engineering, most of the KPIs and stuff all revolve around infrastructure reliability and improving developers' experience. So basically, the noise in the space sometimes leave newbies confused as to where to start. So you hear some people talking about cloud engineering. Do I need to maybe focus on just AWS, Azure, or you hear some others talking about, okay, site reliability. Okay, what do I need to know about monitoring? Is site reliability just about monitoring and stuff? Then the other space talking about, okay, DevOps is end to end. DevOps involves SRE, it involves cloud, it involves basically everything. So it can be a lot for like people coming into the space. And I think I've listened to a couple of like people help me with a couple of previous virtual localhost hour where they're talking about, okay, most questions you hear is how do I get started? How do I get started? And that's coming from a place of all sincerity because it's quite a lot. Like DevOps is a lot because it has a lot of moving parts, a lot of different like responsibility. But the idea is to kind of like give us a breakdown of these things that we hear, the noises that comes here and there, and how to still focus on the key values of being a DevOps engineer, regardless of what your organization might call it. So one of the things we're going to be looking at today, like I already mentioned, is the latest buzzword, which is platform engineering. I don't know if anyone has heard about platform engineering, or maybe Google search or Google ad or something has brought it up, but it's kind of the new buzzword. And I was opportune to actually attend one of their events. Like, so there was this particular day, and my manager then was like, okay, I'm hearing about platform engineering. I don't know how we're going to do it, but I heard there's an event. Would you like to attend? So basically, I attended that event, and the theme of that event was DevOps is dead, long live platform engineering. So when I saw it, I was like, we've not even settled in yet. Basically, people are still struggling, and there's still a lot of debate. And now you're telling us to move on from DevOps and go on to something else. So yeah, I was at that event. It was more, was it an event? It was just like a gathering of like some DevOps, cloud engineers, and stuff to just talk about the trends and all this fun stuff. But basically, what the whole thing about platform engineering is, as we move on, we'll try to I'll try to give us a breakdown what it is. Basically, I'll try to also give us some principles about platform engineering. Just as the way we have like some core principles that are guiding DevOps. So there are some principles that this community that are pushing out platform engineering are like are pushing out also. So basically, according to Gartner, Gartner says platform engineering is an emerging technology approach that can accelerate the delivery of applications and the pace at which they produce business value. So basically, that definition kind of sounds for those of us that probably started our DevOps career with trying to understand what DevOps is and stuff, you would notice that the definition is not far-fetched from what like DevOps has always been about. Just to say that again, basically, like platform engineering, according to Gartner, is an emerging technology approach that can accelerate the delivery of applications and the pace at which they produce business value. Then this community of people that are actually pushing this out, there's actually an official website for platform engineering and this stuff. There's a community and it's kind of going, right? They kind of define platform engineering as the discipline of designing and building tool chains and workflows that enable self-service, emphasis on the self-service capabilities for software engineering organizations in the cloud native era. So platform engineers provide an integrated product, most often referred to as internal developer platform. Another emphasis on the internal developer platform, covering the operational necessities of the entire life cycle of an application. So basically, what are they saying here? That the core responsibility of a platform engineer, or everything that platform engineering is revolving around, is about first providing self-service platform for engineering team, and basically indirectly saying like you're creating like an internal developer platform. So this is the foundation in which this whole concept about platform engineering is built on. And that is the buzz, the fire that has been moving out there, where people are talking about, okay, internal developer platform, self-service, and all this kind of fun stuff. But basically, just to kind of move ahead, like to the principles. So there are some principles that are guiding platform engineering as a, would I say a breakout or an evolution of DevOps, basically. So one of the principal guiding platform engineering is clear mission and role. So the idea here is that for a platform team, there needs to be a clear mission, right? An example is like to build reliable workflows that allow engineers to independently interact with setups, basically. So what are they trying to say here is one of the core guiding principle of platform engineering team is to first have a clear mission. There's a lot going on in DevOps. There's a lot going on in whether you call it DevOps, cloud engineering, production engineering, and stuff. There's a lot of moving parts, right? Sometimes you tend to want to tackle a lot of things at the same time. So the very first thing, the very first principle of platform engineering is having a clear mission and goal. This can evolve over time, but basically you have to focus on something, then you can build on that. Then the next thing is to treat your platform as a product. So the whole idea is one thing with DevOps we know today is DevOps is just DevOps, right? DevOps is a process, blah, 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 blah. It fosters collaboration, communication, whatever stuff. Then there's the world of a lot of DevOps tools out there. So for DevOps, we don't see, basically, we barely see what we do as a platform. So, or a product rather. So for instance, you're working with a company A and company A builds a product A. Now, this product is termed product A, right? Everybody knows about this product. It goes through development lifecycle. There's a new feature, there are bug requests and all. But in the DevOps space, right, what we see happen is we just have like a bunch of tools that we try to bring. Okay, I want to do CI/CD. Jenkins can do this. Maybe GitHub Actions can do that. Okay, let's use CircleCI, for instance. Then, okay, infrastructure as code. Can we use Terraform? Can we use CloudFormation? It's just basically different tools to address different problems. And there's no you can hardly see a platform in this. You can hardly see a product in what a DevOps engineer is doing because you just have like different moving parts and you try to just bring together different technology and it can be cumbersome. It can be like really a challenge keeping track of this. And the fact that you have different tools doing different things and there's no unified entry point to using these tools is very difficult to treat it as a product. So the very second thing about platform engineering, the core principle is like you need to treat your infrastructure instead of using the word platform, you need to treat it as a product in the sense that you have like a core products manager that is responsible to say, okay, while we're treating infrastructure as code, like how we're approaching this, how can we expose this to the rest of the engineering team? Like, how can we, okay, what feature can we achieve in this quarter? Like, what feature are we looking at adding to the next quarter? Just the same way you treat like a product in the particular organization. Another core principles of platform engineering, right, is focus on common problems. So basically, platform teams prevent other teams from within an organization from reinventing the wheel. By tackling shared problems over and over, it's key to figure out what these common issues are. So basically, another thing you have to keep track of, basically not to lose sight of, is the problem that your organization is facing. So today we have different organizations with different problems, regardless of what they are doing, right? Because each organization tends to solve different problems, right? Different business models, basically. Even for organizations that are even in the same space, for instance, fintech, an organization, a financial organization. If you have two financial organizations, I can beat my chest to tell you that these two financial organizations have like two different technical problems, right? Even if their business model is maybe the same thing, because their choice of their developers will probably be developing things in a different way using different technology. So problems are specific to organization. What works for my organization might not necessarily work for your organization. Of course, there are standard practices, right? There are best practices to follow and all, but there's no one implementation that fits our organization. So it's very important, which is why it's one of the core value of the of platform engineering to have for you to focus on the particular problem of your organization. Some organization, their problem is CI, continuous integration, right? Why some organizations, the problem is CD. Why some is actually keeping track of the infrastructure. Like focus on where the main challenge is and build up from there. Another thing, another principle, which is actually very important, is glue is valuable. Glue, like super glue and stuff, right? Glue is valuable. So I kind of like touched a bit about it, about the DevOps today is, I think we kind of approach DevOps wrongly most of the time is because we see DevOps as just implementing or bringing a tool to solve a problem, right? Just throw a tool at it and your problem is solved. So that brings a lot of issue. For instance, in an organization today, in like if you kind of take a consensus, like at an average, an organization doing all this cloud stuff, even if not cloud, right? You see an organization using maybe Terraform, Helm, using maybe Jenkins or GitHub Actions, also running on Kubernetes or VM. Then they're trying to use Elasticsearch and Kibana for logs, some Prometheus or Grafana and stuff. There's a lot of tools, and these tools kind of work independently. And the challenge that comes with these tools is the people you're serving, right, which are the developers primarily, right? You're meant to improve their developer experience. But instead, what we are saying is we're introducing a lot of complexity in the mix. So why do I say this? For instance, we're saying, okay, for engineering team, we need you to deploy applications with M. At a very good, like most cases, what you see is the engineers need to know how to write like Helm charts, right? Then we say, okay, we're doing Prometheus and Grafana for monitoring and all. Then your things start creeping in like, okay, the engineers need to write that prompt cure queries to kind of get alerted on metrics. For instance, we can say, okay, the engineers need to start maybe learning how to write like some GitHub actions, even if we're there to provide some assistance. But at some point, they need to be aware of how like GitHub actions work and all this fun stuff. In some cases, Terraform, which we're seeing heavily, where everybody's going like infrastructure as code, but we are paying little attention of the effects this have on the engineering team at large, because now developers need to learn how to create a Route 53 record from Terraform. It's very easy for the DevOps engineer because it's like your bread and butter, but for the engineering team is not so smooth. I see a lot of engineers struggle with this. So basically the idea, one of the core principles of platform engineering is glue is valuable. So the idea is try as much as possible to glue this stuff together, right? And provide like a unified interface for them to interact with this. Now, this brings about a lot of abstraction, and that's where like your creativity and you kind of earn your paycheck as a DevOps engineer in this sense, but a platform engineer in this sense, because you have to come up with like a way to abstract all this complexity. A developer doesn't necessarily need to know that his application is being deployed by a Helm chart, or needs to know how to write a prompt cure query, or worst is need to know how to write a Terraform code or debug a Terraform script, those kind of stuff. So that is one of the key principles. Glue is valuable. Then the last I have on the list here is don't reinvent the wheel. Again, it seems like we're contradicting ourselves in the case where we say don't reinvent the wheel. So today we have standard tools out there that does this stuff. For instance, Terraform. It's like a veteran in the space for infrastructure as code. We have GitHub Actions. We have Jenkins, which is also another veteran. So the idea for platform engineering is not for you to, as a DevOps team, to build out your own CI tool, right? Some people have actually, like I made mention earlier that there are some group of people that are like carrying this stuff and pushing it out there. And some people actually approach this again the wrong way, which we can't like prevent, whereby you want to build everything from scratch. You want to build your own CI/CD pipeline to suit your team's use case, or you want to build your own abstraction for Terraform, basically. We've seen a lot of problem with that. So one of the key principles is don't reinvent the wheel. So if you have Jenkins doing a good job, stick with Jenkins. So the idea is not to build a new Jenkins server as a platform engineer. The idea is for you to abstracts the way people make use of Jenkins. You don't need to put a requirements for an engineer to be able to know how to debug a Jenkins a pipeline and stuff, right? If Terraform is the way to go, like for infrastructure as code, you don't need to go as a platform engineer to build your own infrastructure as code tool. You can leverage Terraform, but then you need to be able to abstract the complexity of using Terraform, right? So that is the core. I think there are about like 5 principles I have on this my document. The field is going tomorrow. You check online, you see like 10 principles. Next tomorrow, you see like 15. It's kind of wide out there in the space. But basically, what we just need to know, like the take home from platform engineering is actually reducing the complexity, abstracting this complexity from the rest of the engineering team, which is the developers basically. So you don't stand as, because today I can tell you for a fact that DevOps is doing the opposite of what it was introduced to do. Like if we're being sincere with ourselves, I can tell you for a fact where for somebody to deploy a service before when I joined like my first company when I started out, to deploy a service to production, when the developer is done, the developer builds the code and sends you the output. Then all you have to do is to copy this code to the server, basically just extract it. Then you have to restart IIS or your web server, Nginx or whatever you're running behind. So now there was no complexity. You just, the engineer just stick with his code. And when it's done, he just zip the file and send it to you. Now we brought about DevOps, and what are we doing? Okay, you need to learn how to, we're deploying on Kubernetes, you need to learn Helm. Basically, you need to be able to put some certain things in your values or YAML. If this is broken, you need to know how to write a Helm template. Oh, we need a Route 53 record. You need to do this with Terraform because we need to be compliant. We don't want anybody going to our AWS console or whatever to create records. So now you're putting like a requirement on the engineering team to be able to debug or write a Helm chart, learn Terraform, right? You need to be able to write Terraform scripts to provision infrastructure. So if you need an RDS database, I don't need you to go to AWS console. I need you to do this from Terraform. Now, so the developer needs to know how to. So basically, it's almost like most implementation of DevOps is more like, okay, we're introducing a tool and we're still pushing it down to the developers to do this work. And I can tell you for a fact that's the case, because then the developer, you just provide a repository with a CI pipeline that does the Terraform apply. But now the developer needs to learn how to write the Terraform resource, right? Now we are seeing a case where teams, right? These developers are actually learning how to do this. And of course, they are developers, while engineers, they're picking up real fast. And now we are evolving to the space of CDK, especially when it gets to things like Terraform. So now what does this mean now? Okay, say you're a DevOps engineer, you're providing a tool, okay, this is the way to do it. Now the developers are learning. Now they took it a step further. Terraform is stressful. Can we do this with a CDK? So now what we are saying is you're writing infrastructure with native languages like Python, C#, Java, and all those fun stuff. Now, like with time, you run into a case whereby, okay, you really don't need a DevOps engineer for an infrastructure provisioning. The engineer can always do it for himself using a CDK. So talking about infrastructure related work, we really wouldn't need a DevOps engineer with that regards. Okay, that's fine. Then we'll move over to the CI/CD pipeline. Then the DevOps engineer comes in and say, okay, we're using GitHub Actions, for instance. This is how you build your pipeline and stuff. Then again, to be honest, and if we're being fair with ourselves, CI/CD, especially the CI part, personally, I have an issue with CI in the CI/CD. Because to be honest, like the CI should be left for the engineer. The engineer understands his code better. The engineer is able to integrate his unit tests, linting, and all those fun stuff. If there's any kind of security tool we want to put in the mix, like to scan his code, we can always tell him to plug it in. But basically, the CI parts should be left for the engineer. So if the engineer is doing the CI parts, so what would be the hard place to do in a kubectl apply to just maybe apply exchanges, for instance, in the simplest form to a Kubernetes cluster? So we are seeing a lot of a lot of contradiction in this old DevOps, and it's happening in the real world where some organizations we basically have the engineering team just do their whole pipeline themselves. And to be honest, you really would not really need a specific person being a DevOps engineer, because sometimes they tend to introduce complexity that slows the engineering team down, because what works well for the DevOps engineer might not work well for the rest of the engineering team. And most of the time we just tend to push out things that we think is good. And to be honest, that happens a lot. For instance, there are a lot, like tons and tons of DevOps tools out there. And we always find a case whereby, okay, there's a new tool doing new stuff. And mostly what we do is maybe we'll go for this event and we bring up these tools and say, okay, instead of us using GitHub Actions, can we use CircleCI? CircleCI allows you SSH to the runners and stuff when your GitHub workflow is running. So basically, we're seeing a case whereby the engineering team can handle this themselves. But again, it brings up a problem where you don't want your developers basically being in charge end to end, because right, developers can be really careless at times, especially when it comes to security and all those kind of fun stuff. So just to try to like put a point to all this, like, how is the platform engineering different from DevOps today? Because these guys are saying DevOps is dead and platform engineering is the new thing, right? So developers should be able to build, deploy, and run their application service end to end. You build it, you run it. That's like the mantra of DevOps, right? It's usually not the case, but that is what DevOps is saying. We provide the tool, we provide an automation at its core, right? That is what DevOps should be. Provide an automation. It should be seamless for the developers. The developers should be able to do this end to end, like without even knowing they're doing this process end to end. But that's actually not the real case. So, but at the very fundamental of this, right, if you check the ideologies or the core values of DevOps and the new platform engineering they're pushing out there, they're actually not different. Now, the fundamentals still remain, if we're listening properly, is to improve developer experience and for infrastructure reliability, because you are basically, in most cases, like the DevOps engineer is responsible for the infrastructure, right? So this is still DevOps. It's just like platform engineering is DevOps that is disguising, if I'm allowed to say that. But basically, so just like to kind of break this down, what this means, depending on your level, you're approaching DevOps today. So for senior engineers, right, what I'd like to point out is simplicity is simplicity is a feature. Now, the simplicity I'm talking about is how your users, your customers, which are the engineers, the developers, how they are seeing what you're building. So because today we have different tools and it's very difficult gluing all this together. So one thing to keep in mind is simplicity. If you're looking towards simplifying the process you have today, you're as well almost like halfway through in being compliant with platform engineering. So I say it as a call to action for our DevOps engineers, like our senior DevOps engineers that make decisions in organization on the tools and processes to use, to abstract the complexities involved with our various implementations. We are really creative, right? We implement crazy stuff, right? Especially when it comes to CI/CD pipelines, secret handling. Secret handling is a big thing. So many people tend to overlook it, especially when you're running on Kubernetes and stuff. Managing secret end-to-end can be really problematic. And if you try to address some of the issues with secret handling, it tends to step on developers' toes, because then there's a lot of things you need to implement that doesn't really sit well with them. So secret handling, infrastructure provisioning, right? So the whole idea is for the senior engineers that are looking at exploring what this platform engineering and all this stuff is talking about, is basically for you to abstract this complexity into something that is easy for the rest of the organization to basically use. And the whole idea here is, while you are doing this, you're not sacrificing compliance and governance. So basically, one of the things is to improve developers' experience. And for some developers, for some organizations, this translates to giving the developers like free hand to explore and do things as much as they would like to, right? In some cases, giving them production access. So when you're trying to implement platform engineering, you need to also keep in mind compliance and governance, which is a big thing, right? Security is a big thing. So you need to be sure that, okay, if you're giving them this free hand, whatever tool, whatever platform you're building, you can bake in security inside of it, regardless of what you are doing. Security is at the forefront, is the responsibility for everybody in the team, whether you're the engineer, whether you're the DevOps, whether your role is a security engineer. Security is the responsibility of everybody in the team. So another thing for the senior engineers out there is the goal we should always keep in mind is that we want developers to focus on business values. So when I say business values, is focusing on features, bug fixes that directly impacts the product, not having developers spend time debugging a Terraform script, or have developers spend time writing a Helm chart, or trying to get a PromQL query to work, or trying to build there's a lot of crazy stuff out there that we're seeing developers are spending a good amount of time doing, which should not be the case. Of course, again, there's autonomy and efficiency. We need to be able to do this and also be in control when we're talking about autonomy here. So we want to give this flexibility and not being in doing it in a way whereby we lose complete access to our infrastructure, in a case whereby a developer can just come and deploy anything or just introduce anything. We need to be able to know that whatever we're building is compliant in this case, and efficiency, of course, it has to be efficient, basically, whatever thing you decide to build. So because the idea here for the whole platform engineering is for the DevOps teams of today to focus on building an internal developer platform instead of approaching DevOps as a process of using different tools, basically. So if you look at platform engineering, the whole idea is that treat DevOps as a product. Treat it as a product. You build a product. You build why the developers are focused on building the product. You are focused on building a product that is being used by the developers. So instead of having the developers write a Terraform script, you can just provide them with a UI that they basically describe what they want. Or worst case scenario is not worst case scenario. Most times you can just say, okay, provide like a YAML file and say, okay, put this YAML file on Git or somewhere. Then you as a DevOps engineer, you have like your tool to pass this YAML file and basically bring whatever has been described in that YAML file to life. So an idea would be to say, provide a means whereby a developer can say, okay, I need a database. The developer doesn't necessarily need to know if this database is going to run on AWS, which is maybe an RDS instance, or if it's going to run as a container in your Kubernetes cluster. What the developer cares about, to be honest, is he wants a database in dev environments. So you don't need to put a burden on the developer to say, okay, you need to know how to write a Terraform script that creates an RDS instance, and you need to know the best practices of writing Terraform. So basically, that is the whole idea. Like, it's a call to action for the senior engineers to start looking at DevOps instead of bringing about different to more like providing the products, right, internally that the rest of your engineering team can leverage on. Right. So now moving over to like the junior to mid-level engineer. So what is this like? The whole idea for this is like the term of the theme of this whole talk that I'm giving is, for those of us maybe that joined a little bit late, what we're talking about is filtering out the noise while keeping up with trend. Right. So basically, so for junior to mid-level engineers, the idea here is for you not to get distracted, regardless of what we are talking about, right? Regardless of whether an organization chooses to call this DevOps engineering or platform engineering or cloud engineering or SRE or production engineering. the underlying foundation remains the same. It doesn't change, right? So the whole idea is while you're seeing a lot of tools, you go to Cloud Native Computing Foundation website and you see like 100 of tools and you'll be intimidated and looking like, okay, do I need to know this? What are people using out there? I think you should completely take your mind off that because that's a distraction. For instance, if you join an organization today, and they are doing CI/CD, regardless of the tools they are using to do CI/CD. CI/CD is CI/CD. You get the whole concept remain the concept. You build the image, you do whatever test you want to do. If at all you're doing tests, linting and all this fun stuff, and you deploy your code, right? It's very important that we know these foundational principles before we start going to learn tools out there. It's a very wrong approach, right? So we should try to give me a second. So we should try to understand the problem that this tool is solving before we start learning tools, right? So the foundation knowledge is very important for junior engineers, most especially, right? For instance, and like I mentioned, there are never-ending tools out there. You go to CNCF and you see bazillion of tools and you get confused. I myself get confused at times because when I go online, I'll be like, okay, what's this tool doing again? Like, why are we using this instead of this? There's always that debate. Should I use GitHub Actions instead of CircleCI? Should I use Terraform instead of CloudFormation if I'm running on AWS and all those sort of stuff? If you understand the basic foundation of what this tool is supposed to do, you struggle less actually, and you'll be able to make the right decision when the time needs. Just to call out some of these concept and principle. The very first one is, especially for those of us that are looking at getting into this, even for those of us that are actually in the space, right? System administration is it's something we should not joke with. Oh, I don't know if I got that right, but we shouldn't joke with system administration, right? Whether you're running in Kubernetes, whether you're doing Docker and stuff, right? Most of the time, right, as a DevOps engineer or whatever role you have, you implement something. Most of the time you spend is maintaining what you've implemented, right? So we run into issues most of the time. For instance, you're seeing cases like your you're running into like memory issues, CPU issues, you're running into networking problems. If you don't have foundational knowledge of Linux, Windows internals, right, and networks, right, you're going to struggle a lot, right? DevOps is not about building CI/CD pipeline and just going there. You're responsible for a lot of things apart from that, especially for those of us that are more into the infrastructure side, which I am. And it's the same for most organizations, right? So you need to understand Linux internals, right? There's no pressure to maybe go and download a 1,000 pages book and stuff. Just don't neglect system administration in favor of going to learn GitHub Actions and stuff, right? It's very important we get the foundational knowledge of how things work in Linux environment, how things work in Windows. Basic concept regarding network is very important. IPs, gateways, what is NAT gateways, right? Translations, like what are all this stuff, right? You need to understand them because these principles, they don't change, right? Whether you're running on-prem, whether you're running on AWS cloud, you're going to meet networking. You're going to meet things like gateways, routers, you're going to meet like this virtual network, which are synonymous to switches and routers and all this stuff, right? You need to understand the foundation. So when you're going to things like AWS and Azure, they kind of make sense because Azure, for instance, AWS, I don't know, do they call it virtual network or it's Azure that calls it virtual network? These are implementation of real life networking, switching, and routing, right? So if you understand the fundamental principles, like you would even get an idea before, like you know what you're doing before you even log onto your Azure console, basically, and you know what you're looking for. You don't do it the reverse where you go to Azure first and you're saying like, okay, there's a network security group or there is like a routing policy. You find out that you're trying to cram most of this stuff or trying to remember. But if you understand the fundamentals behind system administration, you would struggle less with this concept. Another thing I see often that people really neglect also is in the DevOps space, especially for like the junior to mid-level engineers, like is the software architecture, right? People just know about the buzzword, microservice, microservice, microservice. Okay, Kubernetes, Kubernetes. It's very important you know what led to microservices, the bazillion, if that's a word, of challenges microservices brings, right? Microservices, to me, it brought more challenge or more issue than it came to solve, to be honest, especially from the infrastructure side of things. You need to be able to understand the fundamentals of this. You don't really need to know maybe the internals and implementation details, but you need to know what software architecture is all about, right? How we started from monolith service-oriented architecture, then we moved to microservices. What are the challenges microservices brought about? What are the challenges for developers, right? What are the challenges for infrastructure engineers or DevOps engineers? The other thing we need to look at is container orchestration. Most of us just get deep dive into Kubernetes. Kubernetes is the way to go. Good. But what's the problem, Kubernetes? It's very important you understand the why and the what the problem it's solving, especially for junior engineers. Like, what is Kubernetes doing? Kubernetes is running container workloads. What are container workloads? Like is an abstraction of like maybe operating system, like packed in like this mini box and stuff. Like, why are we doing that? So you need to understand the problem it's solving. Then you need to understand, okay, what makes Kubernetes? Like, you need to understand the concept that this builds upon. They don't just fall out of the sky, you know. So understanding the concepts makes you appreciate the implementation details. So when, for instance, you see that you're running Kubernetes and a pod dies, another pod is created, you tend to appreciate and understand why that is happening, like the thought process that went into that. You find out that you kind of retain that memory instead of trying to remember like what is a pod or what is a deployment or what is a daemon set. You kind of understand it better and it sticks, right? Then I think second to the last is like deployment patterns. Right, today there's a lot of stuff, especially with CI/CD. Like I mentioned, I'm really not a fan of continuous integration part of CI because I feel like that is the focus for the engineering, like the developers. They build that code, they should write a CI pipeline to build it and push it to our container registry. Where mostly you come in is the CD part, because now that is your domain of taking whatever they've pushed to Docker registry or ECL and be able to deploy that efficiently to your environment. So deployment pattern is very important for us, right? Today, by default, we really don't appreciate how deployment works in Kubernetes because we just maybe kill a pod, another one comes up and stuff. Like maybe you have a new image deployed and Kubernetes does a rolling update. Most of us really don't understand these foundation principles. So it's very important you understand it. One thing I want to mention is the push and pull based deployments pattern, right? Our CD today has evolved. We pretty much started with things like Jenkins, where you have a script in Jenkins. Jenkins is very popular and powerful, right? Where you do maybe your kubectl apply or your Helm install and all this fun stuff. Continuous deployment has evolved to like the GitOps approach with things like Flux CD and Argo CD. Now you should understand what these are. And these are categorized into like the pool-based deployment patterns, basically. So you need to understand what challenges these pool-based deployment patterns are solving. Like, why would an organization want to use Argo CD instead of just the typical Helm install or kubectl apply and all those fun stuff? So you need to understand the why and the what's before going deep into all this stuff. Then we have a bunch of other stuff regarding blue, green, and canary and rollouts. Don't just look at implementation details, right? Or a tool that is implementing this. Try to understand the fundamentals. The last thing I want to touch on is infrastructure provisioning. Like I made mention, Terraform stands out in this place, right? Terraform is like the go-to tool for infrastructure provisioning. That is kind of changing if you're keeping up with the trend. One thing is today the DevOps engineers, they're like owning Terraform. Now we're evolving to, instead of writing HCL, which is like the default language with Terraform, we're seeing cases where CDKs are coming up, right? What CDKs? Like cloud development kits, I think if I get that correctly. So the idea here is if your engineering team is developing a product with Golang or Python, for instance, allow them write their infrastructure code with Python and Golang instead of having them learn HCL. So that's where CDK comes into play. Now there's a tool out there that we have Terraform. There's also a tool out there that is making good waves. It's called Pulumi. It's crazy. I think you should check it out also. It does this effortlessly. I think they took their time to see some of the challenges with Terraform and all, and they kind of address most of those issues. So sometimes when you get to a position where you need to make a decision about stuff, don't just go with what most people are using or what you think the DevOps community is using. First, look at what works for your organization, what works for your team, and look at what you think works for your platform at large, if I'm allowed to say that. But basically, so there are CDKs now that are doing this stuff. Terraform has a CDK. I think you can write Terraform codes with Python now, which works well. And Pulumi does a great job also. So basically, this is just to give us like a run through of what like platform engineering is talking about and all those like fun stuff. A lot of conversation. I don't know if anybody has questions and stuff. We can take questions. You could raise your hands. You can ask me anything you want to ask. While I just try to let you guys know that Localhost Lagos meetup is tomorrow. So for those of us that are in Lagos, I think we should try to make it to the event. It's going to be like a convergence of thought leaders. You get to learn a lot, like get to see people physically do some crazy stuff. John, I think you have a question, yeah?
Yeah, so I just want to know about your thoughts on Kubernetes engineers as regards to the platform engineering. Like what I'm actually particular about is the ability to write operators in Kubernetes. So how does it relate to cloud, like the platform engineering that I just talked about a while ago?
Yeah. So the whole idea behind Kubernetes operators is like it gives you the power of like custom resource. Like you create your own resource instead of like deployments. You can create like your John resource or your company resource. Now, what it does is Kubernetes operators is also in line with this platform engineering we're talking about. So, for instance, instead of having your engineering team kind of maybe deploy Helm chat and stuff, or maybe do Terraform and all those fun stuff, you can actually write a Kubernetes operator. And what this operator will do is to get like receive a YAML, like a YAML input that says, okay, I want I want a database, a Postgres database in dev environments. And maybe I want to add this record in Route 53 DNS, for instance. So the flexibility with Kubernetes operator is you can define a custom resource in any format at all. And you have your operator pass this format and create anything backend. So for instance, you can have the developers submit this operator to your Kubernetes, maybe with your GitHub's approach, Argo CD or anything. And your operator would actually create this resource in AWS or create a new container, regardless. That is completely transparent. So the Kubernetes operator, like people are actually implementing this internal developer platform with Kubernetes operator. So it's down to what works for your organization. Like Kubernetes engineers, it's a branch of all these DevOps, like basically, I'm saying they're focusing more into Kubernetes. You can use Kubernetes operators to do basically anything you want to do and abstract away the complexity of having people go to AWS or Azure or having people write Helm charts. You can just get a custom resource definition that basically spins up an infrastructure. I don't know if that answers your question.
Perfectly. So it's like I would say it's a good way to like branch into the platform engineering.
Exactly. So it's a good way to plan. So today people are also using this to make money because they've done the hard work of building an internal developer platform that has a UI that your developers can just log in and say, okay, I want a database in dev environment, or I want to clone an application in pod and stuff. But you can use Kubernetes. Like Kubernetes is like a good foundation to implement most of this with your Kubernetes operator. Yeah. Do we have any other question? Why I try to read through? I think, yeah, I was talking about Localhost. The event is tomorrow. It will be nice to see you guys there. You get to learn a lot and meet a lot of good people. Then there's this DevOps Global Summit coming up April 4th and 5th. It's good to join like this DevOps community, right? To be able to see what is happening, what people are using out there. So you don't, because things are like changing so fast. So you need to basically try to keep up with trends. There's this DevOps Midwest that is happening in April 13th. You can always Google this. And I think these documents, I think maybe Favor is going to like send out this document, I don't know, basically that holds the list of these events that are happening recently and how you could maybe end goal and stuff. But yeah, Wisikat, you have a question?
Yes. Hello, good afternoon.
Yeah, good afternoon.
So this is more of a bit technical question than the general topic, because you were talking about, like earlier you spoke about how like bridging the gap, like how I think it said developers, if the DevOps engineers are telling the developers that they're supposed to there's something about secrets in Kubernetes in a certain way that they're not going to react well or something. So I wanted to just say, okay, pardon my naivety. I'm a DevOps engineer in training. I'm still training, and I feel like secrets writing secret files for Kubernetes is very unsafe, because I was taught that you're supposed to encode it in base 64 and then it push it to version control or something. But then I can easily decode it. So it's so funny. Like, how is that supposed to be a safe way of putting credentials or anything at all in a secret file?
Yeah, just to quickly, you should never like base 64 encode anything and put them in a public place. By default, like in Kubernetes, is actually not even safe because secrets are base 64 encoded, and anybody that has access to your cluster has access to your secrets. So you have to pay good close look to access control. But one thing I have to say about secret management is like very big topic, right? So first, like I've worked on an implementation for secrets management end-to-end. So basically what I had to do then was first figure out a way to encrypt the secrets first in Git. So there are tools out there that does this. Like, of course, organizations have their private GitHub repo that is not exposed publicly. So there are tools like Mozilla Subs. So this helps you encrypt your secrets in Git. Then you can have, depending on your pipeline, right? You can have like encrypt it in Git. You can have Terraform applied directly to the cluster. There are things like external secrets in Kubernetes. You should look that up. So basically what that works is you have a controller, more like this Kubernetes operator. It's a controller running in the cluster. It encrypts a secret for you and it decrypts it when you apply that resource to the cluster. And there's also leveraging things like HashiCorp vaults and AWS Secret Manager and stuff. So there's this concept of secret provider class. It's also supported by the community. So what that does basically for you is you can leverage any full-fledged secret management solution like HashiCorp Vaults and AWS Secret Manager. So once your application is about to start up, now you're not saving your application, you're not saving your secret as base 64 encoded value anywhere. Once your application is about to start up, like when the pod is getting created, it makes a call to HashiCorp Vaults or Azure Key Vault or AWS Secret Manager, depending on what you're using. It makes a call, it gets the secrets, and this is completely transparent to the application, right? This all happens in Kubernetes, right? Because of this, it makes a call to HashiCorp Vault. It gets the secret and it mounts it as a volume on your pod. Then your pod has access to that secret. Then you can go ahead to set that as environment variables, or you can go ahead as just and read it from a file. So there are a couple of implementation out there. I'll just reiterate that one is external secrets. There is secret provider class, and there's Mozilla Subs. If you want to completely get rid of all this stuff, just do Mozilla Subs, encrypt it on Git, then decrypt it on deployments time. So there are a couple of ways to go about it. Yep.
Thank you very, 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 very much. Yes, Evie. Thank you.
Awesome. Do we have any other question? Yeah, Micah, I have to one. Okay, Micah, maybe let me just take Micah. Please, you can always reach me if you have questions. I'm thinking I'm on the Localhost Slack. You can always reach me if you have questions. I have to jump into a meeting, but I'll just take Micah question before I rush out. So Micah, what's up?
Yeah, good day, sir. Thank you. So talking about emerging technologies, yes.
Sorry?
I just wanted to. Can you hear me?
Yeah, I can hear you.
So I'm talking about emerging technologies basically in the
Yeah.
tech space. Most especially, the advent of AI in everything. So
Yeah.
how do software engineers basically um go through these changes basically and adapt to the changes or maybe react to these new changes in AI adoption basically, most especially DevOps engineers that are actually in this space.
Okay, so basically, so when it comes to, you see, part of the mantra of this whole platform engineering and DevOps is, first of all, kind of have a clear mission. So, right, don't, and it's part of the theme of my talk is try to get rid of the noise. Like artificial intelligence and all is great, is awesome, but you have a use case, you have a need for it. If you start thinking about how to maybe use artificial intelligence in your organization and stuff, it wouldn't really make sense. You should always implement things. There are tons of tools out there, tons of processes out there. You should always implement things based on the need for it, right? Artificial intelligence is an awesome tool. It's very important for you to know what it's about. Like as an engineer, it's very important for you to know what it's about. It's good, even better for you to know how it works, right? But there's no pressure at all for you to say you want to implement this in DevOps and stuff, right? There are like few cases, like few use case in your job role as a DevOps engineer to use artificial intelligence to do what you're doing, right? Artificial intelligence at its core build on top of data sets, right? So you need to be able to get a lot of use case, transform that to data sets that you can feed into any model and stuff. But just get a use case for it. If you know artificial intelligence is the right way to go, then you can integrate with whatever tool is out there. Chat GPT, of course, is what's in vogue. I don't know if that answers your question.
Yes, it does. Yes, it does.
Awesome. Thanks, guys. I really appreciate your time for taking our time to join the call. You can always reach me. Maybe if you don't have access to Slack or anything, reach Favor, or you can reach me on LinkedIn and stuff. I'm more than happy to assist us with anything.